Software runs almost every aspect of our modern lives, from the banking systems that hold our money to the diagnostic equipment in our hospitals. Yet, despite this ubiquity, massive software development projects fail at a staggering rate. They routinely blow past deadlines, consume millions in excess budget, and often deliver buggy, frustrating experiences. The root of these failures isn't a lack of computing power or modern technology. We are still relying on industry folklore and misconceptions that trace their roots back 50 years to the early days of computing. Let's watch this play out. Imagine a high-stakes software project, say a new enterprise healthcare portal, is just getting off the ground. The team is assembled, the budget is approved, and everyone involved is highly optimistic. But almost immediately, the team makes a fatal mistake. They treat writing the software like an intuitive art form, assuming developers can just sit down and start typing out code. Without rigorous engineering principles guiding the process, the project is already walking toward a cliff. The first misstep usually comes from the client. They provide a brief, vague statement of objectives and figure the programming team can just fill in the details later. The assumption is that because software is digital, it's inherently flexible and can be easily molded on the fly. This chart shows exactly why that assumption is dangerous. Here we have a project's timeline on the bottom axis and the cost to make a change on the vertical axis. Early in the project, during the planning phase, changing a requirement is incredibly cheap. It's just erasing a line on a whiteboard. But watch what happens as the project moves forward. Once the architecture is locked in and developers have committed hundreds of hours to writing specific features, that cost curve spikes exponentially. A vague requirement early on means the team builds a weak foundation. When the client finally clarifies what they actually want months later, the necessary changes tear through the existing code, causing the entire architectural framework to buckle under the strain. Because the team had to tear down and rebuild their work to accommodate those late changes, the project inevitably falls behind schedule. Panic sets in. Management looks at the calendar and applies a factory floor solution. Just throw more bodies at the problem to catch up. This is a classic management myth, often referred to in the industry as the Mongolian horde approach. In the 1970s, software engineer Fred Brooks documented exactly why this fails. Adding new people to a late project means your current developers have to stop working to train the newcomers. The complex webs of communication grow, grinding actual progress to a complete halt. Desperate, management might try another common tactic, outsourcing the troubled project to a third party, assuming an external firm can untangle the mess. But an organization that lacks the discipline to manage a project internally will struggle just as much to manage it externally. These tactics treat software like a mechanized assembly line. In reality, writing code is a highly complex communicative process. You cannot speed up a 9-month pregnancy by assigning 9 women to the job. The pressure from management trickles down to the programmers. Faced with impossible deadlines, the team starts looking for corners to cut to create the illusion of speed. First, they abandon modeling and documentation. A prevailing myth among practitioners is that writing down specifications is useless bureaucracy, and the only real measure of progress is lines of code on a screen. They also push off testing. Another dangerous myth takes hold: the idea that you can't assess the quality of the software until the entire program is fully built and running. This diagram shows how early technical reviews act as quality filters. By passing the initial design through a series of increasingly fine meshes, teams catch defects early on, when they are tiny and easy to extract. When a panicked team skips these filters to save time, massive errors slip through to the final build. The resulting bugs require time-consuming rework, directly causing the severe delays the team was trying to avoid in the first place. Eventually, by sheer force of will, the team gets the program to run. They deliver the code, pop the champagne, and celebrate a hard-fought victory. But the champagne is premature. Programmers hold a deeply ingrained belief that once the software is delivered to the customer, the job is complete. This chart reveals the reality of the software lifecycle. Historically, between 60 and 80% of all effort expended on a software project happens after it is delivered to the customer for the first time. Because the team skipped documentation, ignored structural design, and rushed the code out the door, the software is incredibly brittle. Every new update breaks 3 existing features, turning post-delivery maintenance into an expensive nightmare. These intuitive myths, that flexibility is free, that more people means faster work, and that coding is an art rather than a science, offer psychological comfort when the pressure is on. Recognizing them for the traps they are is the necessary first step to building software that actually works.